Welcome, I'm Bill Wake. We're here working on a programming language called Tenth, and our focus is on an assembly language implementation using what we call threaded code. I guess there's variations. Today we're focused on if zero, which is going to give us the ability to execute code conditionally. And then once we have that in place with if then else, we'll be able to test recursive code. And we haven't done that yet, so looking forward to it. All right, we left off with a failing test. That's this test for non-zero, and we get a crash. Now, we did take the time to verify that we think the setup is correct. So I think it's failing because we don't do what it says. What the code does, let's see, I guess I have this from yesterday. Okay, so we want to generate code like this. Something gets created on the stack, call it A, and then we'll generate if zero, followed by an address of the end label down here. And the interpretation is check the value on top of the stack. If it's zero, jump to the label specified, otherwise just fall through. Okay, and this, if you were doing the compiler part, this would tell you kind of how to do it, but we're kind of hand coding it in place as if the compiler had generated it. It makes things a little weird for us, but I think it's okay. Oh, and I also need to mention no session Thursday this week. I'm off next week as well, returning February 26th. All right. So now there may be something else wrong. I don't dismiss the possibility at all. But if there is, well, we'll find it as we go. I'm going to take this out and this out. This was just kind of a debugging thing so we could see the memory location of ldict if zero, and that's the dictionary for 01. We use these commands. For debugging purposes, we needed that. For implementation, we don't. And I'll start from the optimistic posture that we're going to implement this and it'll just work. It'll probably take a little more than that. Usually does. Let's see. This word primary, I don't think that helps anything. All right. Now down here we have if zero. Okay. So what it's doing is it's going to pop the value off the top of the stack. So let's do that. Index 0. And we're going to look at it. Well, let's see. We got to keep track of our program counter is x20. It's pointing. Let's see. I guess in terms of this, the program counter points to the next statement. Right now, it's pointing at this numeric value. So I think that's what the error is, that if zero our current one just returns. I think it comes back around in the interpreter loop and says, what am I doing now? Oh, I'm doing this instruction. Well, this is a label in the data space. It's not code you can execute. So it's not a pointer to code. So I think that's why we're getting the crash. So I have a hypothesis. The jump address seemed a bit strange. I think I believe it pointed down here. It may have been off a little, but it was pointing inside the data segment, not the program segment for sure. I guess most of our pointers are with the approach we're using. All right, so if that's wrong, yeah, that won't work. But right now we're coming through. We've incremented the PC. We're ready to execute the next instruction. It should point somewhere that is a code address, or point somewhere that points to a code address, and it doesn't. It points to code, and maybe even nothing. I don't know. What's after the last statement. All right. So, well, I think we have to basically we have to look at x zero and decide what to do, but we need to. Well, okay. We're gonna compare x zero to z xzr, the zero register. So we're going to decide what the state is, and if it's equal to zero, we want to continue through. Otherwise, we want to skip past it. I'll just say L skip if. Put that down here. Now, I guess our situation is we put something in that is not zero. So I suppose we could, in a sense, it's premature to write this code because our test assumes that it's going to pass. So we could just say, let's get the code that handles the passing case. Okay. And, the real thing we need to do is skip x20 past the current instruction. So we'll add 1 to it. Okay, because it's pointing at that label. Let's see if I can get back. X20 will be pointing here at this label. We just want to skip it and go ahead and run the code inside the if. Okay. And then as far as we're concerned, we're done. Okay, skip if won't hurt anything, but we're going to return. All right, my hope is that passes the test. I don't know why I laugh. Make and it does not. Okay. Did we get a different failure? Well, a different address. 54335, 54541. Oh, quite a bit different. All right. If 0 does not jump for a non-zero value, so it should just return. Well, let's look at this code. So we pop that data off the stack because that's what we're supposed to evaluate, and we should either way, pass or fail, we should end up with nothing on the stack, or one less thing on the stack. X20 added X1. Okay. Well, we'll debug it. No locations. If 0, I thought we put it up here, global if underscore if underscore 0 underscore if underscore 0 underscore no locations. I don't know if D, no. Okay. Well, I'm gonna run, but I suspect it's gonna just exit. Logger. Okay. Well, this is our interpreter. Oh gosh, yeah, good point. Ugh. So yeah, that's probably makes it a bus error as well. But okay. LDB. Why doesn't it like that? We can see it there. These seem odd to me. There it is. Oh, minus address. Okay. Oh, we're getting there before. No, I'm pretty sure you're right that it's the 8. It's how many bytes are moving forward. Am I calling if 0 somewhere? Well, I sure thought I was. Maybe we're not. Well, it should be in here. So we loaded the address in X2. So first we store start 2D, then if 0, then push, then end 2D. Okay, so the address should be in there, and then we're calling it here. But I don't know if my theory about calling this through this is correct. Maybe we set up the data stack. We push a 1 on it. And advance it. And then we load the address x20 of elif01. And we go to start 2D. So, yeah, I don't understand why. I mean, maybe it doesn't like underscores. But it picks it up fine here, so that seems weird. Oh, and we had push. I don't know if we can. Maybe it doesn't like underscores in labels. That seems very odd to me because C uses it. C++ really uses it sometimes. Okay. What I think could be weird by calling start to D. Like we're using it 2 levels deep, so I'm kind of testing not exactly recursion. Try say if zero without. Ooh, interesting. Set minus b if zero. Oh, interesting. Okay, so I won't use both versions. Okay. Well, that's good as far as it goes. Yeah, I think there's something funny here because we're calling start 2D, and then the first thing it's going to do. Well, sorry, an interpreter. It 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 resets the stack pointer or the Virtual PC, which is okay, but it leaves us. It leaves us in a weird place. Sorry, it's storing the old one. Yeah, so I think what's going on is we come in here, and then the thing we're pointing at is it's our secondary, which has start 2D, push 1, if non-zero, sum address, and so on. So when it comes in, X20, gosh, it seems like it should somehow X1. No. X20 is the starting point on the secondary list. Okay. But I think when we interpret this, X20 is pointing to start 2D. So it goes another round in, hits the return here, and then it's back. It's back here. I almost think to do it directly, we're just going to call start 2D on that. I'm trying to test. I'm trying to test if zero. I don't really need to test the whole interpreter loop. So let me try it again. So I think we're pointing here. We'll address X20, X0, if zero. Okay, that's going to be this thing pointing to start 2D. So when we call start 2D, it immediately then calls start 2D again. And I think maybe the return address stuff is not set up because we're not kind of calling it in the same way. So what I want to do is add X20 plus 8. Now, I don't know if we're doing too much of that, but so what that does is we're telling start 2D to start at the second line. So this is the start of the list. This is the code, the lead into it, the header that has the pointer to the routine that handles it. Well, we're calling the routine that handles it directly. So I think we want to do that so we don't end up calling it twice. Yeah. Okay. Let's see. Okay. Well, now we can LD core.out, core.test.out, break set minus B if 0. So what do I think is happening? Well, I guess I'm hoping we get here. Breakpoint 1.1, if 0. Okay. So core tested out, run interpreter. Okay, I guess that's just the way it organized things. Core tests. It links in the interpreter as well, so I think that's where that's coming. All right, so if we look at X19, it should be the stack pointer. Okay, and then if we look at X0, that should be the one we put in there. Yeah, and then X20 is the real one. X20. Well, X0 is not what I expected. Yeah. X19 data stack plus 8. Why did that load decrement it? Oh, yeah. Okay. It pops. Okay. So it pre-decrements X19. Oh, we're pointing at plus 8. Okay. And then I haven't executed the step yet. Okay. I'm feeling better. Okay. Now let's read these again. Read X0 is 1. Okay. That's as it should be. Read X19 should be back to data stack. Good. Read X20. Okay, 20 is debug plus 48, and now we can quit this. Run it to get the latest. Okay, and then looking for 408. Well, 408. Oh no, that's pointing into the data segment. It's not going to be anything. Okay, so X20 points to 4088. All right. Now our next thing is add X20 gets X20 plus 8. Okay, I would love to know what's in that memory. Oh, mem read. Let's just do this. Maybe I can go with this. Core tests. I don't know if I can put this afterwards. Yes. Oh, good. Okay, but I want to get up to 4088. 40. A8. That's pretty far down there. 40A0A8. Okay. 10040C. Okay, so if X20 is pointing to C A8, that's this one. Which is 1000040C0, which is down here. All right, but why 2? All right, let's see. 40. Well, this looks like a 4088 is 3F38 push. Okay, so yeah, our alternative, we're supposed to push. Okay, so I think it's okay. This should be the if 0 instruction, 4080, which is 3F58. 3F58 is if 0, followed by a pointer to where it should jump if it's not 0. Did I do the right jump? I don't even know. Oh, we're not even going to worry about it. We're just going to skip it. But it is pointing to C0 because there was a push followed by our 42, which is of course asterisk. Okay. So I feel like we're actually okay at this point. This thing's pointing at 40A8. That's because we haven't skipped it yet. So I'm going to do a step, which should add 20. I'm sorry, add to X20. Okay, I'll read X20. Okay, is now 40B0. Okay, so we had if 0 branch to 40C0, we're going to go to 40B0 instead, which 4088, I feel like I'm this looks, somehow this one looks wrong to me. But 4088, as far as routines, as far as memory goes, is 3F38, which is push. Yeah, we've got a push instead of an N2D here. That I find very suspicious. Okay, but this one's right. This is a push, 42. And then let's check the code on this one. I think X4, X0. Okay, but the last one. Oh, these are so painful. Okay, so it looks to me like X4 and 2D should be in here. All right, we can verify that. Stack should have data. VP should be incremented. Okay. Let's see. This is the push. This is the jump. 4078 is here. 3F80. That's start 2D. Okay, so start 2D. 3F58 if 0 it's 3F38 push 3F8 and 3F98 and okay, so I think the table is right. That, and that's these guys. This one strikes me as wrong. 4088 is 383F as push. 3F38. Sorry. Yeah. So all right. So I think this table's okay. Yeah, there definitely should not be. So I think I've messed up this one. Maybe I skipped past it or something. But okay, we load address x0 is if 0 is where we're writing to. X1 is dict if 0 is where we're writing from. So we're going to put the start 2D in and go to the next one. And then we also went to the next one here, which was if 0. We put N2D in and then skip 2 because we're skipping the data for it. We add 1 to this. Yeah, we didn't do the last add 1, so it's writing the same value twice. Okay. Holy camole. All right, I'm gonna quit. Yes, make. Okay. If 0 passes, yay. Yeah. Why are there 3 pushes? All right. So the first one was in the first one is in the dictionary table. The second one was the right one. The third one was we didn't move to the next entry in the dictionary table before we wrote it. This kind of thing. It's making the test just unbearable to me. Yeah, I don't have a good solution, but it's pretty obnoxious. I mean, maybe we could flip it so you write this redundantly. I don't know. Well, okay. We have to go through the same kind of pain, though, is why I'm worrying about it. So, yeah, my thought was, could I write this and then immediately write it into the slot as well? Would that make it better? Guess I'd have to give you. I guess I would give you a label. I would tell you the offset in the first table and then the offset in the second table, and you would write them there. That might be better. Let's try and write the next test that way and see if we lose our minds. All right. Well, sorry. Let me save. Let's just run make one more time. I think I changed something briefly there. Okay. Good. So we have if 0 works only if the value is true. Okay, because we just have got a lot going on, even for a relatively small feature. Okay. Now, the next test is going to be if zero when there is a zero. So he's going to have to actually do some jumping. And actually, we need another dictionary. I mean, the real change is here, and then the assertions. Okay, so I'm going to keep the same structure and use the same data. It does jump for zero value. Okay, so now this line, we moved a 1. Let's move a 0 in. I think I'm allowed to do #0. I think it'll substitute the 0 register. Maybe that would be a better way to write it. Okay. Oh, and all these things. Okay, so this is the key line. Oh, that is so obnoxious. Okay. All right. I'll put that on the other one too. Okay. I mean, that's like the key difference. And then the assertion is going to be a little different. Okay. Let's see. Okay. So I think this stuff is, the rest of this is the same, but this X0 data stack. Well, I think the real thing is we want to make sure this X0 is the actual value of data stack. No, I think this should be an X1. I think X0 should be move X0 equals X19. So we're going to check that the stack pointer is back to the start and not these two things. Okay. Okay. I would say that's what we're doing. Okay. And did we set it here? X19. Right. Yeah, so here we set, oh no, we don't set X19. X19 plus 8. It seems like X19 should... Oh, there it is. Okay, yeah, we load it to data stack. We're going to make sure, whoops, this test, we load it to data stack. X19 gets data stack. At the end, we did some pushing on it, and the code, if it doesn't do the if zero jump, is going to push some more, or it's going to pop and then push some more. But we don't want the extra stuff on there. We should be back at data stack, which is the empty stack. Okay. All right. So yeah, these two lines are interesting ones. If zero does jump, well, jumps would be enough. For zero value. Okay, so same code, same setup. Only difference is the value we're testing originally is 0 instead of 1, and then the assertion is the stack is back to normal. And this should fail because we execute the push no matter what. Of course, if I put the address in test all, now it should fail. Yay, a simple, straightforward fail. Crash free, that's the kind of stuff we like. Okay, and we're back into core. All right, so now I think the code justifies this. We pop something off the stack, we're going to compare it, and I think I will just try #0 if the assembler is happy. If it's not equal to 0, well, no, that should be if it's equal to 0. No, I'm all confused. If it's true, we want to run it. So if it's equal to 0, I think it's b.eq. If it's equal to 0, we don't want to do the code. We want to only run that if it's true. Okay, let me look up the instructions. Oh, I closed that file. Let me hide. All right. And we haven't done a lot of comparing. So, okay, there's b.eq. Yeah, we compare something to 0, beq around it. Okay. Somewhere I made a list of those. I'm going to have to reorganize my pages and get something that's just sort of the assembly cheat sheet and the LLDB cheat sheet and that sort of thing. All right, but I think this is what we want. Pop it, compare it to 0. If it's equal to 0, we want to skip. If it's not equal to 0, we want to skip. Oh, interesting. I guess in this one, we need to branch to the end. Branch to end if 0. Okay, because this does things we don't want to do. It has to do a indirect branch instruction. X20 be the address of the end if. Here. No, it's the sorry. Yeah, that's a way to look at it. It's the address of the end of the if. But the address we're doing, right? It's well, so the line 60 jumps over the branch address to the end, because it doesn't want to do that. And then it continues with the pop and whatever else goes on. This case, we are skipping to the end. So we need to load that address that X20 points to, and then branch to that. So, which I think is load address. We can use X0 as temp. And it needs to be X20. Okay, so here, now do we have to increment that? Well, I think that's going to be the new X20. I think we said we can do it this way. So we're going to take the X20 is pointing to the memory location with the proper value for X20. So we're going to load that memory location into X20, which means the next statement to be executed will be the one after the end if, the end of the jump. Okay. We don't have to increment it because that would create a little weirdness, because if we load it into this, we're incrementing the thing we were trying to load. That seems wrong. So, and we don't want to increment it anyway. This is the exact value we want X20 to be. What instruction should you execute next? Well, it's pointing to something in the data area. All right. So, didn't save, did I? I guess I did. Okay. Sure. All right. So, I guess it's a little weird. I'll go back to my picture here. So when we execute the if 0 and we're in our method, we pre-incremented it, or we post-incremented it X20. So it was here. We decided where to go and we incremented it. So now it's pointing to this thing here. This is an address, this address down here. And so if it's true, we just skip over, move the pointer down one. If it's false, then we're loading this into X20. So now X20 points at the end, or the code after it. Okay. X20 starts off, it points to, this is the address of the end if. Okay, so where should you go if the if is false? Well, I don't know if I'm naming this in a confusing way. If 0, the name is a little confusing. It's the address containing, X20 points to this cell, and this is our list of statements. But this cell contains this address, which is the address of the code after the if statement. So if the value is 0, it goes down to it says that X20. So the next thing to be executed, it can't be this, because this is not a code word. It's in a data value, but the data value is an address. So it changes the data value to here. Yeah. But so the thing is, I'm not sure the name, because it's like, it's branching if it's equal to 0. like, I don't know, would skip if zero or jump if zero. I mean, this procedure is for our implementation of the if statement. It's not a word that anybody's going to put in their code. We won't even make it accessible to them if we do it right. But it's weird, like, I don't know how to say it. If a method called if zero, which actually runs if it's not zero. So I think the name maybe should be non-zero. I don't know. If non-zero, do the stuff. Otherwise, skip it. But the actual if control, the actual thing in here is a branch if equal, equal to zero. Maybe I should just leave it as if. I don't know. If check, if test, if clause. I don't know. Yeah, if it's really if true. What's weird is, like, this is not what's happening. It's skipping it if it's zero. It's not running it if it's zero. Yeah, maybe run if true. But would if true do it? Okay, yeah, let's change this name to if true and see if we feel better. Okay. Boy, rename is not so easy in assembly, is it? Don't make clean. Yeah, zero is false. Okay, good. All right. Okay. Boy. Wow. Good stretch after that. All right. Yeah, let's make this easier to write or to make sense of, maybe. Yeah, I think the macro. Well, I definitely can make a macro for writing the dictionary cells that is simpler than this, right? What I'm thinking is you would say um, dictionary entry L dictive true. I don't know if I can get this. Well, let's spell it out and then see what we can do. Okay, so this would be start to D if true, push into D. Right. Maybe it's almost like this, like dictionary start. L dict if true one. Okay. And then I don't need those in here. And this is like dictionary add. Okay. Um, yeah, I think this would be um, kind of tolerable for this block. So we're going to say we're writing into this dictionary. Whoops, this dictionary, addictive true, and then we're going to keep a variable. We're going to keep uses x0. Okay. Right. So let's define the macro. Macro dictionary start. Okay. Whoops. All right. Well, this is that. I gotta put another macro. Okay, just the name. Yeah, because we don't really need X1 for any purpose here. We just use it once and we're done. So I could have, I could have put them interleaved these and it would be just as meaningful. So I think, I think that should be the equivalent of that. I'm just going to cut it and see how that goes. Kind of a weird refactoring. Yeah. Invalid operand. Well, this should have been entry. Oh, am I not allowed to do this? Oh, this would suck if true. Oh, I call it dict label. Okay. Try that again. Okay. I'm liking it. Okay. That helps. That solves one problem, or at least makes it tolerable. We'll put these up at the top. They're really for this test, at least the way we are now. Okay. Okay. Kind of use the same language here. Okay, we use the same dictionary. Oh, I did on this test. I don't know, I feel like I messed something up. X0 elf true. Okay, maybe not. Good. Okay. Now these. I'm going to say secondary start. And again, I'm just making up a way to do this. Okay, so the secondary start, it needs to know what? Well, he needs to know where we're going to write. Yeah. So this is dictionary. No, I think maybe LF true. Okay, now so I'm going to assume x0 is if true 1, which is the secondary. And x1 is the dictionary. Okay, so I think you're going to have to give me the offset into the dictionary or the entry number 0, 1, 2, 3. That would be good. um, so 0 gets 0. All right, because that's start 2D. I'm going to say secondary. And copy address. No, it was for add. I mean, you're adding to the secondary, so you're filling in this thing. One. Yeah, I'm not sure if I'm getting there. All right, so that's 0, 1. Then I want to do a secondary skip because I'm putting data in after if true. Then I'm doing push is 0, 1, 2. Data for push, and then secondary add 3. Would I? Yeah. So it's start 2D 0. I almost want those for comments. Although you could mess yourself up. Well, I do because I need somehow to reference this cell. So I'm doing it in sequential order. This is 0, 1, 2, 3, and you're saying I'm going to call 0 as start 2D. Now what I'm debating is like if I did this, that would tie those. I would have to put pounds on them. That would tie them together explicitly, but then like, am I using that number in there? I mean, compared to this, right? 16. Now that we need. Yeah, exactly. Um, and this is definitely kind of mini language designed for us, but like somehow I can't use the labels, unfortunately. Like I'd really like to just use Start2D and let it use do it, you know. And it's a stupid assembler limitation as far as I can tell, but this assembler doesn't let us put relocatable names in data segments. So and stores, yeah, okay. Um, Now the if putting the numbers in, I could probably. I could probably do that, and then it's your responsibility to make sure you have 0, 1, 2, 3, 4, or whatever in place, not duplicated anywhere. Okay, but um, I think I could get this working. All right, let's see if that macro. Let's try to write the macro, get it working, and then we'll work on improving it. So macro secondary start, and we're going to give it the secondary and the dictionary. Okay, so secondary start, we're going to do this. X0 is the secondary. X1 is the primary, the dictionary. Okay, I think that's all we need to start with. Yeah, diction, secondary skip, secondary add. It's the index, dictionary index. Okay, so skip just increments x0, yes. Okay, so add x0, x0 plus 8. Okay. And then this one, well, we did this sort of thing. Okay. X1, all right. Somehow I have to shift that dictionary index. So, dictionary index, I got to take that left shift 3 because it's 0 gets to be 0, 1 should be 8, and so on. Okay, so I want to store X1 is the address of the dictionary. I think I need a, well, I do. right, because we could have two pushes in the secondary. So yeah, I can multiply it, but there's a built-in left shift that will do it if I can find the right mode. I don't know where the modes are. Simple addressing modes, yes. Oh, you can't let me search the whole thing. Oh. Did I put something in my notes? Summary. Branches. Oh yeah, there's my conditions. Branch and debug stuff. Calling. Addressing modes. Okay. This one. Register A plus register B times 2 to the nth. Yeah. So now, does this register A, register B? Okay, we'll have to see if this actually helps us. I don't know if there's a better one. No, those change the register. We don't care about that so much, I don't think. Well, we can only add one of them at a time, so who knows? Okay, so what I want to store at X1. Yeah, we might need to register an extra register. So the dictionary index. So if we had a register pointing to the dictionary, X1. So X1 plus the index shifted should be the right value. Okay, so let's say, now I don't know if I can do store into X8 increment. Oh, yeah, like I said, PDP 11 was nice that it would let you just do this kind of automatically. Okay, register immediate offset value. So my thought is that we would position directly. So the auto increment on X1 we would not do, we're not doing auto increment, but the increment. I want to say like X2 gets X1 no, maybe it's like X2 gets dictionary index. Okay. And then no. Wait, add ours. Can I do this on the right? X1 at the X0. Let's move X2 gets, it should be X1. These are indirect. X0, X. Yeah, I want to do somehow I want to do something that's like LSL dictionary index. Okay, so I want one shifted to the dictionary index. So two to the, no, is that all right? I want a one left shifted n times, so times to the nth, right? Oh, really? It's 8 times to the nth. So, n. Sorry. Okay, somehow I'm going to store x2 in the end. I'm not going to do this increment for you. Okay. So what should increment is x0, the secondary, because we're working our way down the list. x1 I want to directly access. So I want x2 to be x1 and this is the only one that lets you do LSL, is indirect, which is a load or a store. I don't think I need that. I just want x times 8. All right, let's get the offset. Okay, I'm going to call x3 the offset is multiply. Offset is dictionary index times 8. Is that, well, the orders may be backwards. Now, I don't know if I can do that, but if I do, then I want to do move x2 gets x1 plus x3. X1's constant. Wait, there's a mul add instruction. LSL3 would be 8. Yeah, no, I think it's got to be a multiply. Let's try for mul add. Is that only floating point? looks like it. Okay, too easy. All right. Yeah, so the way to get an index, right, is you take the size of the cell times the count, and that gives you the offset, and then we'll access that, offset it from X1 the dictionary by that, and store X2 in X0 and move X0 forward. You think I was right with X2 having the index? Well, I think now, and I may be able to do this at compile time. I don't know. But I get the index, I multiply it by the size of the cells. So I'm going to be that many off the starting point. The starting point is always the dictionary start, which is an X1. So I'll add that. Sorry, this is add X2 gets X1 plus X3. I think that's what I'm trying to spit out here. And now X2 is the right thing. Okay, I don't know if that will build. Well, am I calling it? Yeah, let's see if it builds. No. Macro instruction. Yeah, that I wondered about. I don't know if I can do that at compile time. Kind of feel like that's not going to be loud. Ooh. I really need 4 registers. Golly. Feels like a lot. Oh, I'm still not happy. X3, X4, pound 0. Well, $113. Sorry, 151 2. 152 2. Multiply does not like constants? Immediates? Oh. I don't want SIMD. I just want the plain old multiply and divide. Oh, there is IMAD. But here's multiply. RD times RN. There is no immediate. Good grief. Yeah, it's worth trying. Well, I think there you're saying, let's do you think I have to put the parentheses? Or do you think I can do this? 8 times 2. I'll take this one out. We're not trying to run, we're just trying to compile. Huh. Okay. Now let's try dictionary index. I think it's going to get upset by the pounds. Yep, but I can take them out. Okay, that's a little promising. Okay, so we're going to add x1 with this value passed in and not need a million temps, which is good. All right, nice catch. Nice idea. All right, so we'll load the dictionary, load the secondary, load the dictionary, use a temp register x2 to get the dictionary plus the offset, store that value in x0, increment x0. Otherwise, we just add to x0. Okay. Now, I think that gets us through most of this. What's funny here is if true 1, add x0 plus 16. So plus 0 plus 1, sorry, plus 0 plus 8 plus 16. So we're getting there. Add x1 is x0 plus 24. Okay. I think the part I have up there is this. I don't know if I can. It doesn't let me do them in bulk. All right. So this is the back patching for the store instruction. Okay. But I think it would almost be better if this were just like a constant. And then we could just put that in there. I think that would almost read better, but let's get this working first, of course. All right. Okay, so that seemed to work for that one. Boldly cut that out. Okay. And then this one's the same. In the next test. Okay. All right. Well, we're going to document these a little, but I'm going to pull them up to the top. All right. So, secondary start. Sets up x0 and x1 to point to initial secondary and dictionary. updates x0. Well, I think the real thing is it stores dictionary address at x0, updates x0, uses x0 through x2. Okay. Okay. Let's push this. All right. Let's take that break, 3 or 4 minutes, and we'll come back and pick up the next thing. Else clause, probably. Welcome back. All right. So we've done the if. Where do I have that? There we go. This case, if 0 and so on. This one is the same stuff, except that it needs a jump. And this jump is just an involuntary branch. Okay. And then we changed the name on this, so let me do that here too. DRUE. Okay, so we'll have to, I guess we need to implement a jump that skips over a block of code. Once we have that, we can form our own if then else, and that'll get us able to test our recursion at last, which early signs aren't good, but we'll get there. All right. It's a new thing. Okay, so this is a new function. I don't know. I think it's going to start a lot like this. Maybe it's not as fancy. Okay. And test end. Okay, so we need start 2D, end 2D. We need a push. What's something I can do that will show up? Well, we'll add jump, and I guess push will do it. Okay. Okay. Right. Okay, so I probably can use that same secondary and dictionary. We only need, yeah, I think we're, let's find this. Addictive true 1. I'm going to call this L test dictionary and let a bunch of tests share it. I'll replace them all. Okay. And then I'll give it some extra room. You don't have to use these. And actually, I don't want this on the end now. Okay. And, no, I don't think it's an if true else. I think it's just we'll assemble it from the pieces. So if we because if true else, right, we would have to know. Well, I guess we'd have to come back in and patch them, and in the end, we still have to do a jump somewhere. So, yeah, I think we'll just do the jump and build up from it. It would it would be the same thing if we introduced like a case statement kind of thing. At the end of each branch of the case statement, you have to jump to the end of the whole statement, you know. So I think it'll be useful for that. And then repeat until probably needs it, maybe not. We'll see how that does. I sketched it out here, but I didn't put the translation in. If non-zero, no. So I don't think that does. Yeah. Oh, while do does. Yeah, right. You test at the top and jump back. So I think it's a useful little component. All right. So what I want to do with it. Okay, this is jump skips over code. All right. Text dictionary jump push, and that sounds fine. The secondary itself, I'm going to name this one too. I'm going to make it let's make this L test secondary. Place them all. Okay. This one, this is 0. A jump is 1. Okay. Then we want to do a push and a value. I didn't think I need a secondary data. And then 3. I'm going to get these numbers yet. Give these things numbers as well. All right. All right. So we've done that, but we haven't. Jump needs an address. So we're going to skip him for a moment. Whoops. All right. So start 2D, jump, skips over this. There's an address. Sorry, push data. And then N2D is 3. Okay, I think that's the right code. Then we got to do a patch, kind of like this thing does. Well, no, if I... I bet I could do something for that too. Like address or target or something. Give it +1 +2 or something and let it multiply that too. I don't know. For now, All right, I had to add secondary data in as, yeah, secondary data. This stores a value in the next secondary cell. Okay, and so this should be move. Well, let's write it and then worry about it. X2 gets X2 plus value, and then store X2 in X0 auto increment. Okay, so we'll okay. So if I load in 42, I add 0 plus 42, and then store that 42 in the next cell. Okay, whoops. And let's try it in here. We had that 42. Secondary data 42. And I might need the pound on this one. Yeah, let's see if that works. Secondary operand. Oh, XZR. Ugh. Okay. He does in fact need this. That's kind of confusing. And valid operation still. Let me go back to these addressing modes. Rn plus value. RA bang in. Okay, so you leave off the exclamation point and you just get an offset. That still seems wrong. Add X0, X0 pound 16. Okay, so what's your complaint? Add X0. Well, maybe that's just a move. X2 gets value. Okay, that's progress. Yeah, XZR is 0 or WZR is 32-bit 0. Why it didn't like it for that, I don't know. I thought we had examples. Well, we had examples of register plus value, but a move's somewhat simpler conceptually anyway, so it should be less work for something. I don't know if I can I use it literally here? That would be interesting. And the jump error is, yeah, no, you can't. Okay. The error is we don't have, our test isn't written yet, and but it's calling jump somewhere. Okay, so adds jump. All right. Yeah, now this. So this is saying at this address, put this number. So plus 0 plus 1, 0 plus 8, 16. That's the jump. Put the number for 40, 24, 32, 40. Is that right? 0, 8, 16, 24, 32, 40. 3 is in 2D. Okay. Yeah, that's the patch. Okay. All right. So the act, we don't need anything on the stack. I don't think we'll need this data. Well, we need the stack loaded. Sorry, that part's okay. We don't need to push this on the stack. We load up X20, starting it offsetted by 8 because we don't want to test the interpreter 2 levels deep. Okay. Now, yeah, this is sort of the same assertion. We should skip the push and so the stack should be where it started, not added to. Okay, so I believe we can put jump in. Jump and just do a return. So we should get a some sort of bus error kind of thing, like we did when we started today with the VPC trying to interpret a data as the wrong thing. Oops, global. Okay, where's my fail? I didn't add the stupid. There we go. Nice crash. No, this test doesn't have an if. It's just got, let's get down there. So we do 0, which is start 2D, jump. We get the data value that points down here. And if we don't jump, we're going to push, that's 2, a value 17. So I'm expecting to see a 17 on the stack. Not, well, I'm expecting it's going to have incremented the stack pointer and not have left it there. Okay. Okay, so this is sort of like the other, core. All right, so we don't do any compare or anything like that. We're just going to get this this value. So we're going to take the value at the current instruction pointer, which is the target of the jump, and load that into the instruction pointer, so it becomes the thing jumped at. I didn't change 24 to 40. Oh, it's too clever. I think it's 40 because it's adding it back in. Yeah. So X0 is the secondary plus 16, but then we add 24 to that is the 40. I'm open to improving that. Yeah, the sum is 40. Like, ugh. All right, let's see if this works first, and then, well, let's see. Maybe I should do a simple. No, I'll just see if it worked. I want to see it fail. I want to see it fail differently, I guess. I'm just going to do add x20 gets x20 plus 8 and skip this part. So we're just going to skip over that thing. This should fail with a fail. Yeah. Okay. And then putting it in should pass because we don't need to increment it because we're replacing it. Jump is a lot easier. No wonder GoTo was in these programming languages so much. All right. Jump skips over code. Okay, so I think I'm happy with that. At least it works in Tiny Refactor. Add jump, which jumps over code. Okay, now let's deal with that 40. Let's make this better. So store x1 well, I think I could say x0 plus 16 and then 40 and take this out. So this is the secondary address plus 40 is what we store at x0 plus 16. It's still kind of weird. Okay, it works. But I think the real thing is we can do this. We can add a secondary for it, a macro for it, I believe. The 16 here is because this is 0, 8, 16. It's the one we skipped. All right, so we don't need the index of it to do that. If we did this, now this is, well, this is 40 times 5, right? 0, 1, 2, 3, 4, 5. All right, so this could be, we could say this is 5 statements down. And, well, we're giving it the target. Yeah, we're saying it's the fifth the fifth line of the secondary, the fifth cell. So I would love to have secondary, maybe target is 8. That would be kind of nice. Okay, 0, 1, 2, 3, 4, 5. I guess it'd be 5. The 8 is coming from the word size. Okay. Whether it needs a pound or not, I'm not clear, but we'll see. I guess not, because it's getting multiplied. All right, so let's write this. Okay. Okay, now I don't know if make sure I'm thinking about this thing right. 0 is the start 2D. 0, 1, 2, 3, 4, 5 is where that's going. Okay, so it's going to the fifth entry, fifth row of that block. Okay. So it's, well, let's take the code we have. That. Okay, so X0, the test secondary, that's already in X0. So we don't need to load that. And then X1, that's our multiply, add X1. X1 is the dictionary there. Okay, so dictionary is the thing that's getting multiplied. X1 is, well, I want to do something like this. I'm trying to get X2 to be the address. X0 is the address, the secondary, then pound 8 times / cell number. Okay. And that X1 is trashed. X1 should not change. Okay, so we want to store this in X2. X2. X0, comma. Pound 8. Okay, so it's kind of like this one, but it's working on the other cell. Okay, so we're going to take the secondary address, 8 times the cell number, gives the sum of those two gives us the value we want. Yeah, we don't want to change X0 secondary. Oh, you're right. Yeah. Do I need to keep that secondary around? I guess I'm going to. I would probably choose different registers if I were starting over, and I guess we could look at that, but all right. So now, you good catch again. X2 should be X3, but we're storing this in X0, right? So it starts off the secondary. It's the offset from the original secondary. We get that offset, and then we store it at the current slot in the secondary. Okay, I kind of think that's right. I don't know if you can get by with fewer dictionary entries. Target 5. All right, so let's take these 3 out. Nope. Okay, that still passes. Okay. Just out of paranoia. 5, 4, 3. Let's change it and see the test fail. Before we trust it all the way. Good. Okay. So now that was this load target. Okay. This one does the same thing. This skip is really a target because it's if true. Okay. 0, 1, 2, 3, 4, 5. And then theoretically this is not needed. Good. And this was secondary data. $42. Okay, so now everybody's using this. Let's take this out. And we're not quite using that here. But I think it boils down to the same thing. 0, 1, 2, 3, 4, 5. Data 42. This comes out. This can come out. These comments can come off. Because I think the real usage reads much more like it. And then let's just give ourselves some extra room. All right. Okay. Cool. All right. So I think we've definitely improved the readability of the test quite a bit. You still have to know a bit about what's going on, and you couldn't just mix in registers willy-nilly with it. Yeah, a lot less to type, and I'm much more confident that, like the first time through where I forgot to increment something, I'm pretty sure that won't happen with this approach because it does the incrementing. Okay. And then even though it's a lot to set up, I think that's better. All right. Well, that's a pretty big to-do. Okay. If and else, really. Did I put the right label on today's work? If 0. Okay. Well, it's now as if true. If 0. Okay, so if via if true, support else via if true and jump. Okay. So I think we can start writing the test for this. Well, the interpreter tests, they have kind of that same character, don't they? How to get those macros to them? It's really not AS unit macros. Sorry. I think we're going to pull those into a core tests macro. Tests, and I'll put it down here. A new file. Where's my empty? Oh, assembly file. Core tests dot macros. Okay. And we'll pull that from here. And interpreter tests. Okay. Boom. Could not find file core test.macros. Core tests dot macros. Now this thing. Okay, let's make sure what's going on here. There is no core test.macros. They're right. What is this? Show and finder. Oh, it's in that stupid 10th folder again. Ugh. Okay. I don't know if I can put it in here. Show this in the finder. Oh, I just screw myself. All right, let's. That made the file go away. Oh, did it? Okay. Oh, good. But I don't think it's there. No. Okay. Well, let's delete. Let's revert to this. Pull them again. See where it's putting it. Okay, let's move it up a level. Okay, fine. I guess I did that. Okay. Good. All right. Make. Good. And we'll push. Okay. Now, in our interpreter tests, see if I can at least start. All right. Well, we're going to do something. We got to see something happening. Okay. So let's have secondary call secondary. Another secondary. All right. And then we're going to need a data segment. Line, get back to a text. Okay. In here, we're going to put L dict test dictionary. I think I can say just fill 10. L secondary 1 fill 10. Okay, so we'll give each of those, create one for each of those. And then this is going to be L test dictionary. Okay, I guess build dictionary into secondaries. Okay. Yes, that's the good part. All right, now the tricky one. All right, let's pull that from core tests. We'll take this for a starter, but we'll have to change it. Well, let's take all this. Shape's kind of right. Okay, so now L test dictionary, that's fine. All right, we've got start 2D. I don't need if true. I guess I need well, I'm going to call dict add, but I'm going to call secondary 2. And that's the tricky part. Okay, because we haven't filled in secondary 2 yet. This is secondary 1 from LTest dictionary. And then we're going to need one that's similar for secondary 2. Okay. So I'm going to start 2D. They have to start that way. Add 1 push. Well, what do we want to do? The second, maybe I'll start with the secondary one. Start 2D for sure. And then he's going to push a 5. Okay, and that's fine. And then target is routine 0, 1, 2, 3. Okay. Maybe just he's data. Five. Secondary add routine 3. I might want to make those dictionaries change. All right, but I don't have what this one does. Yeah, we're very close. One more minute, I think. Let's call. Well, let's just try calling 0, 1, 2 and check it. Okay, so I think that's our load. That's all this stuff. Okay, and then I'm going to say TBD. And we'll pick up there. Leave a note in here. All right. Okay, so we got if and else done today. And well, secondaries calling secondaries, we don't need if and else for. We can just call them. But recursion will need the if else. So I'm hoping tomorrow we can quickly get this going and then get the recursion going. And that'd be a great way to finish the week. All right. Thanks again for joining today. Hopefully I see you tomorrow, 2 to 4:30 Eastern or 7 to 9:30 p.m. UTC. We'll pick up here. Thanks. Bye-bye.